Okay, next problem is integral dx upon 3x square plus 2x plus 7. Do it. In between you lost touch of integral. So you take 1/3 common out. Integral dx divided by x square plus 2 by 3x plus 7 by 3. Now you have to complete the square. Integral 1/3 dx upon x plus 1 by 3 square adjusted minus 1 by 9 plus 7 by 3 equals, this is 20 by 9. Is that right? Which is equal to 1 by 3 integral dx upon x plus 1/3 square minus plus 20 by 9. So this is square of root 20 by 3. So x square plus a square in the denominator. Therefore, integral is 1/3 1 upon root 20 by 3. That is 1 upon a tan inverse x plus 1/3 x square x plus 1/3 denominator root 20 by 3. Simplify, you will get 1 upon root 20 tan inverse plus 1 upon root 20. That is what is the solution. So essentially, because it is quadratic, you can complete the square, and after completing the square, this term is going to be linear inside bracket, and hence ax plus b is this term, and hence we can always TKP this to the standard formula and get the integral. E42, E43. Integral dx root of 5 plus 4x minus x square is equal to. Do it. Okay, using method of completing square again, you get the final answer as sin inverse x minus 2 upon 3 plus E44. Integral 3x plus 4 divided by x square plus 6x plus 7 dx. Okay, now find out your method for solving this. Now if you were having 2x plus 6 in the numerator, then it was easy problem, but you don't have 2x plus 6, you have 3x plus 4. So it should be an algebra problem than an integration problem. That is the hint I can give. Now the technique here is, you want 2x plus 6 in the numerator and you have 3x plus 4. So 3x plus 4 is equal to a times 2x plus 6 plus b, correct? So 2a plus 2a is equal to 3, implies a is equal to 3 by 2. And 6a plus b is equal to 4 implies 3 by 2, so 9 minus b is equal to minus 5. That makes our integral in two parts, 2x plus 6 upon x square plus 6x plus 7, and outside 3 by 2 dx, that is first part, minus 5 integral 1 upon x square plus 6x plus 7 dx. This is y dash upon y, or fx dash upon x, f of x dash, f dash of x upon f of x. So the answer for this is 3 by 2 log x square plus 6x plus 7 minus 5 integral 1 upon, now we have to complete the square here, so x plus 3 bracket square minus 9 plus 7, that makes it minus 2, and then it is x square minus a square type, therefore second term will be minus 5 upon 2 root 2 log x plus 3 minus root 2 upon x plus 3 plus root 2 plus 6. This is second term, this is first term. That is what is your answer. This plus this is your answer. Any questions? So adjust numerator such that if numerator is linear, then this is going to be the case. Adjust it in two integrals. This is of earlier kind, first kind. Problem number 42 kind. This dash of x upon f of x. So log of this. Easy. Next. E45. Integral x plus 1 divided by radical x square plus 4x plus 5 dx. Do it. Okay, method for solving this is similar to the earlier. You adjust the numerator in such a way that it is derivative of the quadratic. Inside radical is the only difference here. So you should manage with those coefficients and you will end up getting two integrals. The first solution of first will be radical x square plus 4x plus 5, and solution for second will be minus log inside bracket x plus 2 plus radical x square plus 4x plus 5 plus c. Okay. Have you understood? I mean, you are supposed to adjust this, and the adjustment, if you want to know, plus 1 is equal to 1 half 2x plus 4 minus 1. This is the key, algebraic adjustment. So with this you get this integral, with this you get this. E46. Now you should be able to do this quickly because it is similar. Little change. Maybe hardly any change. So why should I give it to you? There is no change. But the answers look exactly same. Okay. So 46. Maybe for the purpose of numbering I am giving you, because otherwise our numbering will go wrong. X square minus 6x plus 4 dx. Okay, everyone get the correct answer now. It is exactly similar to 45. Okay, answer for this question, exactly same method. So 3 times radical x square minus 6x plus 4 plus 7 times log x minus 3 plus root of x square minus 6x plus 4 plus c. Okay, that is what is the answer for E46. E47. Integral 3x square, sorry, 3x cube plus 4x square plus 12x minus 7 divided by x square plus 2x plus 5 dx. Do it. Okay, this is yet another simple integral because you have degree of numerator polynomial greater than the denominator. So first you are supposed to perform long division and hence you will get integral dx minus 2 plus x plus 3 divided by x square plus 2x plus 5. So this is combination of many problems. So you have to solve the first integral, which is 3 by 2x square minus 2x minus, this is our friend earlier problem number I think 44, something similar to that, and it will end up having two integrals, two answers, half log plus 2x plus 5 plus an inverse x 1 by 2 plus c. Okay, good. Now there is one more type before we really shift to altogether new integral form. E48 dx upon t plus cos x. Okay, try your luck. Up to now, today's lecture, whatever we have learned is denominator essentially is a quadratic equation, whether direct quadratic equation or a root of quadratic equation, but denominator is quadratic equation, then it is always method of completing square. Okay, and if numerator is constant, then direct. If numerator is linear, then split it into two, derivative of denominator and constant upon denominator. And if numerator has degree equal to or greater than the denominator, just perform long division and solve it. So that is the one family of integrals that we have done in the morning. Now this is another family where you have trigonometric ratio and some constants. Try it. I think I had mentioned this earlier that whenever it is something like this, tan x by 2 is equal to t is the substitution. Okay, and then you have to figure out in terms of t, I think you will get some quadratic etc. whatever. So do you want me to solve this? I can do it. This is equal to, if I am putting tan x by 2 is equal to t, it is half sec square x by 2 dx is equal to dt, and therefore dx is equal to 2 dt on 1 plus t square. So 2 dt on 1 plus t square divided by 3 plus cos x becomes 1 minus t square upon 1 plus t square. That denominator 1 plus t square gets cancelled and hence we get integral 2 dt upon 1 plus t square plus 1 minus t square What are we getting here? 3 plus 3t square plus 1 minus t square is equal to 2 times integral dt upon 2t square plus 4, which is integral dt upon t square plus 2. Correct? If this is the case, then the answer is 1 upon root 2 tan inverse what? Tan x by 2 upon root. Okay, understood? Couple of more problems of this type. E49 integral dx upon 13 plus 3 cos x plus 4 sin x is equal. Fine. Okay, the answer for this, again the substitution is tan x by 2 is equal to t, and you will get answer 1 by 6 tan inverse 1 by 6 times 5 tan x by 2 plus 2 plus c. E50. Integral dx upon 1 plus sin 2x is equal to. Then if we put 2x is equal to t, 2 dx is equal to dt, dx is equal to dt by 2, then it becomes integral 1 upon 2 integral dt upon 1 plus sin t. Okay, and then if we substitute tan t by 2 is equal to u, then we get half integral 2 du 1 plus u square divided by 1 plus 2 u upon 1 plus u square is equal to cancel integral du upon denominator cancel, so 1 plus u square plus 2u, which is equal to integral u upon u plus 1 bracket square. Right? So चुकलं काय?
सर बरोबर आहे.
बरोबर आहे. मग उत्तर काय येणार याचं? That is u plus 1 raised to minus 2. काय येणार उत्तर याचं?
-1 upon u plus 1.
-1 upon u plus 1. u is equal to tan t by. That is what you have done. Alright, good. That is -1 upon 1 plus t. ठीक है. But then I had some other answer which is written. Let me write down that answer also. Someone might get it, or it is completely wrong. I don't know. But for many years, I have this answer written in my notes: 2 by 3 tan inverse 5 tan x by 2 plus 4 upon 3 plus c. For this problem, this answer is also written in my notes.
But there is one more for
One more.
half of half of tan x minus pi by 4.
Half of tan x minus pi by 4 is also yet another answer. That is what he is saying. So good, let me write down all the answers. I'm not sure how they have got this, but then hope Pranav has got this and all others. In fact, I am also getting the first one. First one I have not written. Okay, the answer for this as per this procedure is minus 1 upon 1 plus tan x plus c. This is the third answer. Okay. Okay, last one in this series is E55. E51, sorry, E55, E51. Integral cos alpha cos x plus 1 divided by cos alpha cos x, cos alpha plus cos x dx. Try your luck. Okay, in this problem alpha is constant, so cos alpha is a constant term and x is our variable. So it's a typical problem where if we consider this one as cos square alpha plus sin square alpha, we get cos alpha cos plus cos square alpha plus sin square alpha upon cos plus cos x dx. Right? So if we take cos alpha common from first two terms, we get cos x plus cos alpha upon cos alpha plus cos x. That is your first integral plus integral sin square x upon cos alpha plus cos x. This is sin square alpha. This is constant upon constant plus cos x dx. So, and this is cos alpha direct. So, x cos alpha is the integral of first part. Second part you need to find out. So, I think you should be able to do it now. Check what is your answer. So, the answer is oh, the answer is Rajavardhan Gentle is equal to x cos alpha plus sin alpha log side bracket tan x by 2 plus cot alpha by 2 divided by tan x by 2 minus cot alpha by 2 bracket complete plus check whether you are getting. Now the next thing is very important technique of getting the integral called integration by parts. You must have used it in physics, integration by parts. And here it is important, how do you get the formula for integration by part? Let f and g be differentiable functions of x. Okay, so if we take derivative of f of x into g of x, what will we get? We will get f of x into g dash of x plus f dash of x into g of x. This is simple derivative formula. And now if I take integral of both sides, this implies f of x into g of x is equal to integral of f of x into g dash of x plus integral of f dash of x into g of x. And then it is rewritten saying that if I want to find out integral of f of x into a function who is easily integrable, g dash of x is easily integrable and its integral is antiderivative is g of x. So this term dx, I mean both places dx. I don't know, its parents cannot, is equal to f of x into g of x minus integral f dash of x into g of x dx. Okay, so this is what is the formula for integration by parts, but then it is written like this: integral of u into v, product of two functions, is equal to u into integral of v minus integral of v into derivative of u. This is how you are supposed to remember. This and above one is same. Integral u into v, that is f of x into g dash of x. It's a product function of two functions. You have a choice of selecting first function. This is first function, this is second function. Integral of second function should be easily doable. That is what is the requirement. Okay. So if that is the case, then product of the functions can be easily integrated using this formula, provided this integral is solvable, and if you are lucky, this integral is easy, and hence you will get the answer. If this integral is equally difficult, then you are stuck. You cannot do. But majority of the integrals can be solved using this formula. Amazing. Because second integral suddenly happens to be easy, and that is how it works. So this is a proof for the formula that you are going to use for integral using integration by parts. That is the theory. Now practice. Okay, as far as sequence of choosing first function and second function is concerned, there is a thumb rule. Thumb rule means it is not a theorem or axiom, it is experience. Experience says LIAEE. Okay, the logarithmic function is the most difficult to integrate. So from this, if you have logarithmic and algebraic function, then your first function should be logarithmic, second function should be algebraic. Exponential is the easiest to integrate. logarithmic is the most difficult to integrate. So this is as per difficulty level of integration. That is what is this. Suppose you have algebraic and trigonometric functions product of the two. Then first function should be algebraic, second function should be trigonometric, because trigonometric function is relatively easier to integrate. If you have inverse trigonometry, I is for inverse trigonometry multiplied by exponential, you should consider first function as inverse trigonometric function, second function as exponential, because integration of second function is doable. Okay. Let us solve couple of problems, few problems, so that you get to know the whole game. Example number 52. I is equal to integral x cos x dx. Now x is algebraic, cos x is trigonometric. So using integration by parts, first function u, second function v. U is equal to x, v is equal to cos x. Maybe if you want I can solve this. Anyway it is easy, therefore let me solve. You solve the difficult ones. So answer is u into integral of v, x sin x minus integral of v, that is sin x, derivative of u into 1 dx. So second function is also easy now. X sin x minus plus cos x. So this is simple. Its derivative is also simple. But if we don't have integration by parts, it is going to be extremely difficult to get this from this. If we integrate, if we differentiate this, we of course will get it. That is why this integration is important, because here the second function, second integral is easy. If second integral is easy, it works. And maybe first integral that you have is difficult. So as far as second term is concerned here, it does not have it direct. I hope you have understood. 53, example 53. Okay, before showing you, if you make a wrong choice, because LIATE is algebraic followed by trigonometric, that is what I did and I got the answer. But suppose this is thumb rule, you do not have to follow every time, and suppose you make it like cos x as a first function into x as second function, then what will happen? Let us see. U into integral of v, x square by 2, minus integral of x square by 2, that is integral of v, into derivative of u, that is minus sin x. So now if you see this integral, if we rewrite 1/2 integral x square sin x, it is more complicated compared to x cos x, because power of x has increased, and therefore you will have to be considerate while choosing first function and second function. See, what we are trying to do is we are trying to find the way out. If this way we are going out earlier, we will follow that route. If that way we are going to go out earlier, we will follow that route. We don't have any choice. We are stuck. Therefore, trial and error, whichever way works is good for us. Okay. So all the integral calculus, indefinite integral calculus, or finding out antiderivative is keep trying and find the most easy way of getting out of your problem. And in this case, if you choose x as first function and cos x as second, you come out easily compared to this. This is going to be, I'm not that this cannot be solved, but this is difficult compared to the given integral. E53. E53 is integral tan inverse x dx. Now, visible only one function, but there is another which is invisible. Okay, let us do it. The second function you can always assume is 1, and therefore u into integral of v. So tan inverse of x into integral of v is x minus integral of v, which is x, derivative of u, 1 plus x square dx. Right? And if you can solve this using our previous experience, we will get x tan inverse x minus half log 1 plus x square plus c. This is the function whose derivative is tan inverse x. Amazing. As a formula, let us derive this integral log x dx. करा सोपं आहे. Log x LIATE log. That is why it is not easily integrable. So log x into 1. So x log x u into integral of v minus integral of v into derivative of log x is x dx. That makes it simple. X log x minus x plus c. E54. आता काय माहिती का, it is very easy, boys and students. Example number 54, integral x tan x sec square x dx. Okay, the answer for this question is half x tan square x minus half tan x plus half x plus c. You have to consider this as u because tan x sec square x is a derivative of tan square x and with some constant etc. So if this is your v and x is your u, then the job becomes easy. Okay, we will solve few more and little more difficult problems on integration by parts next lecture. For today, it is done.